rendering or visualization assistant. The projected salary here is $58,000 a year.
And the source uses this highly poetic phrase to describe them, which I loved.
Yeah, a translator who speaks in light.
Right, because if blueprints and floor plans are like the dry grammar of a building, the visualization is the emotional hook.
Okay, that makes sense.
And in environmental architecture, this visualization has a massive secondary job. It's not just making a pretty picture for a zoning board. It's showing performance narratives.
Okay, let's unpack this for a second. What does a performance narrative actually look like in a rendering?
Well, think about it from the client's perspective. If you hand them a giant spreadsheet proving that a specialized green roof will lower cooling costs by, say, 12%.
Their eyes are just going to glaze over.
Exactly. But if the rendering assistant tunes the exposure and sets up this beautifully lit hero shot, showing the cross-ventilation arrows sweeping naturally through a bright, airy lobby,
Oh, I see.
or showing how the seasonal solar angles perfectly hit that green roof in midwinter, suddenly, the sustainability looks deliberately designed.
It feels integral to the beauty of the structure.
Right, it's not just a bunch of ugly, expensive solar panels bolted onto the roof as an afterthought.
It's actually part of the aesthetic, so they are the ones who secure the client's emotional and financial buy-in.
Precisely, they make the green features look indispensable.
But securing the buy-in is really only the start of the headache, right? Because the moment the client falls in love with the picture and signs off, the accountants step in.
And that requires an entirely different type of defense.
Which brings us to our next role, the junior specifications assistant. They're making about $59,000 a year. And the source says this is where architecture stops being vibes.
And becomes a procurement script.
Yeah, a procurement script. What a phrase.
It's a critical transition, honestly. The specifications assistant writes the literal, legally binding rules for what actually gets installed. They build a procurement script that dictates, for example, low VOC requirements.
Okay, so VOC meaning volatile organic compounds, the stuff in cheap paint and carpets that off-gases harmful chemicals.
Right, the stuff that gives you a headache in a newly built office.
Got it.
So they mandate that the contractor cannot use those. They set strict recycled content thresholds for the steel. They specify the exact chemical makeup of the air tightness membranes.
Oh, wow.
Yeah, they take the beautiful green story that the visualization team just sold, and they make it legally enforceable in a court of law.
Wait, really? So you're telling me a $59,000 junior assistant has more power to save the environmental integrity of a multi-million-dollar building than the lead architect?
Pretty much, yeah.
How do they actually enforce that when the client inevitably demands budget cuts later on?
By making it a breach of contract to use anything else, if we connect this to the bigger picture, the specs assistant is defending the project against its absolute biggest predator.
Which is?
Value engineering.
Yeah.
Value engineering is the industry term for when a project goes over budget and the client starts demanding cheaper alternatives.
Right.
Without a rock-solid, enforceable specification document, all those beautiful, sustainable materials in the rendering just get quietly swapped out for high-carbon, toxic, cheap alternative when no one is looking.
It's kind of a brilliant contradiction when you think about it. You have the rendering assistant making the building look breathtaking with light and shadows.
Yeah.
And then you have the specs assistant writing the driest, most boring legal text imaginable about flooring glue and seal it.
But they're actually fighting the exact same war.
Yes.
Yes.
One persuades the client and the other traps the contractor into actually delivering it.
They are the shield for the entire environmental integrity of the project. But a legally binding blueprint doesn't mean the building will actually perform well in the real world.
Right, because before anyone picks up a hammer, someone has to stress test the math to make sure they haven't just designed a massive energy hog disguised as a green building.
Exactly. Yeah. Because anyone can slap the word eco on a brochure.
So we need to know who is actually running the simulations. The sources call these folks the data wranglers, and their whole job is to prevent sustainability theater.
Which is a great term.
First up is the Building Performance Data Assistant, making around $60,000. They work in what the text calls the quiet engine room of sustainable design.
And their daily reality is managing the raw inputs and outputs across energy, comfort, and operational metrics.
What does that look like in practice?
Well, they track EUI energy use intensity, which is basically a miles per gallon rating for a building.
Okay, that makes sense.
An architecture team cannot act on data they can't read, so this assistant logs every passive strategy decision so the impacts are measurable.
Here's where it gets really interesting to me. Reading how they work, I realized the Building Performance Data Assistant is basically building a fitness tracker.
A fitness tracker?
Yeah, think about it. A fitness tracker logs your invisible inputs, your resting heart rate, your steps, your sleep cycles, to give you a picture of your health.
Right.
This assistant is logging the building's invisible inputs, Things like occupancy assumptions, scheduling, and plug loads.
Plug loads are a fantastic example of invisible data.
Yeah, for anyone listening, plug loads are just the energy used by all the random things we plug into the walls. The computers, the monitors, the 3 different coffee makers in the break room.
Right, because if this assistant doesn't meticulously track that mundane data.
The engineering team might design an incredibly efficient air conditioning system that completely fails the moment 300 people plug in their laptops.
Exactly.
Yeah.
And to take that fitness tracking to the next level, you have the junior energy modeling analyst at $70,000 and the junior materials and embodied carbon analyst at $71,000.
Okay, what do they do?
Well, the energy modeler runs complex HVAC scenarios and tests different insulation levels. But the carbon analyst role is particularly nuanced. I think it highlights a major shift in modern architecture.
How so?
They act as the bridge between material choice and climate impact. They have to extract quantities from the 3D models and apply something called environmental product declaration data.
Which sounds incredibly dense, but reading the source, an environmental product declaration, or EPD, is essentially a nutritional label for building materials, right?
That is a highly accurate way to look at it, actually.
So instead of telling you how many calories and carbs are in a box of cereal, an EPD tells you exactly how much carbon it costs to manufacture and transport a specific steel beam or a batch of concrete.
Yeah, exactly. The carbon analysts build baseline comparisons early in the design phase, comparing, say, standard concrete versus low-carbon mix, before architectural changes get too expensive to make. But the fascinating part isn't just the data hygiene. It's the human element. A highly effective carbon analyst learns to present carbon choices to the lead architects as design choices rather than moral lectures.
I found that detail so fascinating. It's purely a psychological tactic.
It is entirely tactical. Think about it. If a 20-something analyst walks into a room of senior award-winning designers and lectures them on their moral duty to the planet,
They will be completely ignored.
they will.
Oh.
But if they present an embodied carbon reduction as an elegant design solution, perhaps an opportunity to innovate with an exposed timber structure or a new, lighter facade system.
The senior architects will champion it as their own brilliant idea.
Exactly.
So we have the vision, the legal protection, and the deep data proving it actually works. But spreadsheets and carbon nutritional labels are invisible.
Right.
At some point, all of that math has to translate into the physical shape, the curves, and the actual atmosphere of the rooms you and I will eventually sit in. How does a spreadsheet become a wall?
This is the realm where hard science meets human comfort. Consider the junior environmental designer earning $62,000.
Okay.
The source explicitly notes they aren't just the sustainability police. Their primary function is to turn performance into geometry.
Turning performance into geometry. Can you give me an example of what that looks like on a Tuesday morning for this designer?
Well, it means they're looking at the thermal data from the modelers and deciding exactly how deep an exterior window shade needs to be.
Oh, wow.
They have to calculate the precise angle that will block the harsh, high summer sun to keep the building cool, but still allow the lower winter sun to penetrate and warm the space.
That's incredibly specific.
It is. They adjust the glazing ratio, too, which is the exact percentage of glass versus solid insulated wall. They take a performance target and use it to carve the physical envelope of the building.
And working right alongside them is the daylighting analyst, making $69,000.
Yes.
The text says they are shaping atmosphere with mathematics, which sounds like a magic trick, but they are analyzing something called daylight autonomy.
Which is a great concept.
Yeah, I had to look this up while reading the source. Daylight autonomy is the percentage of time a room can be lit entirely by the sun without needing to flip on a single artificial light switch.
And achieving high daylight autonomy is a very delicate balancing act. They aren't just trying to flood a room with as much light as possible.
Right, because putting in giant windows is the easiest way to accidentally build a greenhouse that cooks everyone inside.
Exactly. They're looking for the right light in the right places. They run simulations to ensure the sunlight won't cause blinding glare on a computer screen at 3:00 p.m. in November or create uncomfortable radiant heat spots.
So in environmental design, daylight analysis directly affects the well-being and the productivity of the people inside.
Yes, very directly.
Which brings up the junior building science technician at $68,000. They deal with the strict physics of heat, air, and moisture.
A crucial role.
Because if you get that wrong, the source notes the building just becomes a long-term experiment in mold, drafts, and energy waste. And I want to pause here and connect this to anyone listening.
Yeah, this is relatable.
If you've ever worked in an office where you are freezing in July because the AC is blasting and sweating in December because it's drafty, that means the team failed at this exact step.
A total failure of building science, yes. The technician is reviewing envelope details to mark potential thermal bridges.
What's a thermal bridge?
A thermal bridge is a pathway where heat bypasses the insulation. Imagine a steel beam going from the inside of a warm building, cutting right through the wall to support an outside balcony.
Okay.
Steel conducts heat beautifully. So in the winter, that beam acts like a punctured pipe, leaking the building's interior heat straight out into the freezing air.
Oh, that makes sense.
The technician coordinates risk assessments to stop that from happening, which also prevents condensation and black mold from forming inside the walls.
Okay, I have to push back on something here regarding this whole phase.
Sure.
If the environmental designer translates performance data directly into geometry, and the building science technician is reshaping walls to stop thermal bridging, does that mean the climate and the math are actually what dictate the artistic shape of modern sustainable buildings?
That is the big question.
What happened to the architect's imagination?
This raises a really fundamental question about the evolution of modern architecture. Historically, a starchitect might design a wild, gravity-defying shape purely for its aesthetic shock value.
Right, and then force the mechanical engineers to stuff it full of massive heaters and air conditioners to make it habitable.
Exactly.
Yeah.
But in deep sustainable design, the environment is essentially a co-designer.
Wow.
The sun's path, the prevailing winds, the physics of moisture, those mathematical realities sculpt the building. The architect's imagination is still present, but it is deeply constrained and guided by the physics of the climate.
So form follows performance.
Form follows performance.
That completely flips how I look at those slanted roofs or those deep, recessed, almost fortress-like windows on eco-buildings. They aren't just trying to look futuristic or edgy. The math literally carved those shapes to survive the local weather.
Exactly. But surviving a digital simulation is very different from surviving a construction site.
Which is the perfect pivot. We now have a mathematically perfect, legally protected, beautifully rendered 3D digital model. But now it has to survive the brutal, chaotic, and messy reality of actual construction.
Right. And the sources call this final group the guardians of reality.
I love that title.
As the text beautifully puts it, this is where drawings meet dust. And the front line of this is the construction administration assistant making $66,000.
So imagine standing out in the mud and the dust of a live construction site. This assistant is managing requests for information, submittals, and site reports.
They're the ones making sure that when a contractor, who is usually running behind schedule, tries to substitute a slightly different, cheaper window seat.
Or alter the thickness of the insulation.
Right, someone has to catch it. Because those tiny, seemingly harmless changes on site can completely destroy the airtightness and the performance of the entire building.
And while they fight the physical battles in the mud, you have the code compliance assistant at $66,000 and the permitting coordinator at $74,000 fighting the bureaucratic battles.
Which are just as tough. Passing a sustainable project through city administrative gates is incredibly complex right now.
Yeah, we're looking at navigating rapidly evolving municipal electrification mandates, new embodied carbon policies, and stringent stormwater regulations.
And a late-stage code surprise discovered during permitting can force a massive, multi-million-dollar redesign.
To stop those redesigns, you bring in the junior BIM coordinator at $72,000. BIM stands for Building Information Modeling.
This role is fascinating.
Yeah, they are troubleshooting these massive, centralized 3D digital models that are shared by all the different engineering teams. Their job is to ensure the shared reality of the project doesn't turn into what the source calls a chaotic collage.
Think of it like air traffic control for digital blueprints. You have structural engineers placing steel, electrical engineers routing miles of conduit, and mechanical engineers plotting massive ventilation ducts.
So the BIM coordinator runs health checks and clash detection software on the model.
To make sure the plumbing flight path hasn't accidentally been routed straight through a structural steel beam.
Because fixing a virtual pipe intersecting a virtual beam costs $0. Fixing it after the steel is poured and the pipe arrives on site costs tens of thousands.
Precisely. And rounding out this group, holding the highest salaries in this cohort, we have the architectural technologist at $76,000 and the sustainability coordinator at $73,000.
Okay, what do they do?
Technologists operate in the exact zone where abstract design becomes buildable reality. They figure out the micro details of how materials physically join together so the building envelope functions as a performance machine.
And the sustainability coordinator is the ultimate watchdog, ensuring the green goals aren't just a slide in the concept deck.
Right. They are tracking the thread of sustainability through the entire life cycle, from procurement through documentation, right down to the final construction sign-off.
Look closely at this data, and it makes perfect sense why these guardians of reality command the higher end of this pay scale, the mid-$70 K range.
It really does. If a rendering assistant makes a mistake with the lighting in an image, maybe the client is slightly less impressed.
Sure.
But if an architectural technologist fails to detail a joint properly, or a permitting coordinator misses a new electrification code,
Hmm.
the firm faces unbuildable designs, massive energy failures, delayed timelines, and severe legal liability.
They're the ones who keep the project unbroken as it crashes into the real world.
Exactly.